Welcome back to trigonometry. In this video, we're going to talk about solving triangles. And when you're doing triangle trigonometry, this is really the mathematically central part of it. A lot of times we do story problems where you have some real-world situation, and then there's lots of stuff like drawing the picture and setting it up right. But it usually comes down to solving a triangle. Okay? And the idea is that a lot of times we want to measure something, but it's hard. We want to measure some distance or some length of something, and we can't access it directly. It's really hard to directly stretch a tape measure from here to the moon, but there are easier things we can measure. So we measure something easier, like distance along a path, and then we use trigonometry to compute the thing that's hard to measure. Okay? So you know some things about a triangle, and you want to find out other things about a triangle, and that's what solving a triangle really is. So when I say we want to solve a triangle, that means to find all the lengths of all the sides and all the measures of all the angles. And you, of course, can't do this if you don't know anything about the triangle, so you'll always have some information to start, which you think of as the stuff you do know how to measure, and then you use that to compute the rest. Okay, so let's try it with a simple example. I should mention in this video we're just going to solve right triangles, do some stuff with them later, and then there are ways to solve non-right triangles, mainly the law of sines and law of cosines, and we'll get to those later. Okay, but that'll be another day. Today we're just doing right triangles because they're the easiest ones. Okay, so we just have some triangle. We want to solve it. Typically, you need at least 3 pieces of information to determine all the things in a triangle. And we do actually have 3 pieces of information here. It looks like we only have 2. We know there's a 60-degree angle and a length 10 hypotenuse, but we also know that the third angle is a right angle. So we really know 2 angles and a length, and that's enough. Okay, so when I say solve, I mean find all the side lengths, all the angle measures. So the first thing I would suggest is to name things. Definitely want to give stuff a name. It just makes it so much easier to talk about it. So I'm going to go ahead and label my angles by capital letters A, B, and C. It's pretty common to just label the vertices instead of writing letters inside the angles, although you can write letters like inside here too. I could call this theta or something if I wanted to, but I'll often just call that the angle B instead because it's easier to label things on the outside where you have more room. Okay, so I've labeled everything. Great, fine. How am I going to actually find any of these things? Well, the next step is to find an equation relating one of the unknown quantities to 2 of the known quantities, or at least, all the rest of the known quantities that you need. So we want to find an equation relating one unknown to known stuff. So you could, of course, write lots of equations. We have lots of stuff labeled now. I could go ahead and write, oh, well, I know that tangents of 60 degrees, that's A over B. But since I don't know A over B, that's not very helpful. Instead, what I want to do is I want to write down an equation that doesn't involve 2 unknowns, just 1. So how can I do that? Well, I know C is 10, so maybe I could talk about the cosine of 60 degrees. So maybe we have cosine 60 degrees equals B over 10. Okay, now I'm cooking because I only have 1 variable in my equation. That leads me to step 3, solve. Okay, so that tells me, oh, do I know the cosine of 60 degrees? I do. It's 1/2. So 10 cosine 60 degrees equals B, which means 10 times 1/2 equals B, which equals 5. Okay, so now what I recommend is that you solve and plug in for what you found, because that can help you to find the other sides. So now I know B equals 5, and I can use that to find A or angle B. Remember, I need to find all the sides, all the lengths. So then all I want to do is repeat. Now I know what B is, but I still don't know A or angle B, so keep going. Okay, so what other equations can I write? How about, oh, I don't know, sine of 60 degrees. So I have sine 60 degrees is A over 10. I know the sine of 60 degrees is root 3 over 2 times 10 equals A. So that's A. That's going to be, what, 5 root 3? And then I could, if I wanted to, use inverse trigonometric functions to find angle capital B, but instead I'm just going to use the fact that all the angles in a triangle add up to 90 degrees. So that means that B plus 60 degrees plus 90 degrees equals 180, but normally in a right triangle we just say the two non-right angles add up to 90 degrees. Okay, so that tells me that B is 30 degrees. And then I've found all the quantities. I know A, I know B, I know angle B, solve the triangle. Okay, so what other situations can you do this in? Suppose we don't know any angles except the right angle. We just know two side lengths. We still know three things about the triangle. We know two sides and an angle. So this is actually enough to solve. First of all, I'm going to label everything, right? Always start by labeling everything. So let's call this C, angle C, and then A and B. And I guess if you want, you can label the known sides. You don't really have to. Let's call that B, and 5 equal A. Okay, so how are we going to solve this? Well, you could find, there are lots of options. You can kind of do whatever you want when you're solving a triangle. There's no correct order, but I'm going to go ahead and find C first because I really like the Pythagorean theorem. So the Pythagorean theorem tells me that C squared equals 2 squared plus 5 squared, which is going to be 4 plus 25 is 29. So that means C is plus or minus the square root of 29, but because it's a length of something, it's just square root 29. No fussing with pluses and minuses anywhere. So now we've got all the sides, we need to find two of the angles, angle A and angle B. So we need some equation involving A, for example. So what can we say? Oh, well, how about the tangent? I mean, there are lots of options again. Let's say we know the tangent of A is equal to 5 halves. So how am I going to solve that for A? Well, that's what the inverse trig functions are for. So that means that A is the tangent inverse of 5 halves. Remember, that's saying that A is the angle whose tangent is 5 halves. So if you know this offhand, that's great for you, but I certainly don't. So I'm going to ask my calculator, make sure I'm in degree mode, and then I want the inverse tangent of 5 halves, 68.199 degrees. Make sure you write degrees after your angle measure if you're in degrees, because if you don't write degrees, it means you're in radians. Okay, and now if we want to find angle B, again, we have lots of options. We could say B is the tangent of 2/5 and use the inverse tangent, but it's probably easier to just use that all the angles add up to 180. So we know that B is going to be 180 minus the right angle 90, so we really just get 90 degrees minus angle A, so that's 68.199. And now this is a good thing to know. When you're using a calculator, I don't just want to do 90 minus 68.199. Okay, because that's kind of rounded, and you can round your final answers, but it's best to work with full precision in the calculator whenever you can to avoid rounding mistakes. So I'm just going to say 90 minus the answer, minus, and then if you hit second, and then the negative sign down here gives you the answer. So it'll take whatever the last answer was and do 90 minus that. That tells me that B is equal to 21.801. And it doesn't matter that much here where I'm just adding or subtracting, but when you start applying trig functions to things, those errors can really compound after you're rounding. So again, you can round at the end. That's fine. You have to, right? But you don't want to round in the middle if you can avoid it. Okay, so you might have noticed that I always name my triangles the same way. I always say that the right angle is C, the hypotenuse is little c, and things like that. And that's because there is a standard naming convention for these things. So how it works is this. We always use capital letters for the angles. If you have more than one triangle, you might need more than A, B, C. But capital letters for the angles, or the vertices, we really call them the same thing. And then we use lowercase letters for the side lengths. And we always want the side length letter to be across from the angle letter. Okay, so if I just draw some triangle somewhere, usually we use C for the largest angle, so I would call this angle C, and then lowercase c is going to be the side that doesn't touch that angle, so it's the one across from it. If I label this angle A, little a should be the side across from angle A. And if this is B, then that would be little b. Okay, it's just a convention. You can label things however you want, but this is how everyone does it, so this is how you should do it too. Okay, so let's solve one more triangle. Suppose we have triangle ABC here, and we're told A is 3, A is 20. So little a is 3, big A is 20 degrees. more precisely, how are we going to solve it? Well, the same way as always. I would suggest writing the labels right on the picture. It really helps to see what's going on. So that's 20 degrees, A equals 3. And having this stuff just on the picture, somehow it just really helps me to see, oh, well, now I can do like sine of 20 degrees equals 3 over C. Okay, so let's go ahead and solve. You can use, again, whatever ratios you want. You can find cosine of 20 first, or it doesn't really matter. But we do know we can do it this way. So we know the sine of 20 degrees is 3 over C, which means that C is 3 over sine 20 degrees. I'm going to put that whole thing into my calculator instead of finding the sine of 20 degrees, rounding it to 1 decimal place, and then dividing 3 by that. So I'll take 3 divided by sine 20. And now I know that C is 8.7714. I'll just say 8.77 here. Okay, so now what do I need to find? Angle C and side B. So why don't we go ahead and find angle C next? I know that, well, I could use trigonometry, but I'll just use that C is 90 minus 20 degrees, which is, of course, 70 degrees. Put it in the picture. Really helps a lot, believe me. And then what else? I guess I have to find little b. So let's say tangent 70 degrees is equal to b over 3. So b equals 3 tangent 70 degrees. And what is that? 3 times tangent 70. And I get 8.24. Okay, so again, my triangle is solved. I found all the sides, all the angles. I'm good to go. Okay, so next video we'll see how to use this to actually solve lots of cool real-world measurement problems. And with that, I think I'll be done. I'll see you in class.